It seems that I have real difficulties finishing this video because of the battery. So we finished by saying that if I take this polynomial and divide by the leading coefficient, which is in 0, by this expression, then I get this to be 0. So hence alpha is a root of x to the n plus bn minus 1 over bn, x to the n minus 1 plus dot 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 plus b1 over bn x plus b0 over bn. And this polynomial is monic. It has coefficients in f and is of degree less than d. So that's a contradiction because the polynomial of degree d was the minimal polynomial, which contradicts the minimality of f. So that means the assumption that at least one of the b's must be non-zero was false. So b0 equals b1 equals bd minus 1 equals 0, i.e. the set is linearly independent. Okay, and this finishes the proof of the fact that the set 1 alpha all the way to alpha to the power 1 less than the degree of the minimal polynomial is a basis of f alpha over f.